Lesson 10-2, Simplifying Radical Expressions. Our essential question today is how do you write a radical in simplest radical form? Our first vocab word is radical expression. A radical expression is an expression with a radical in it. Now, a radical means a root. So we are going to focus particularly on square roots today. So then simplest radical form means that we're going to write our square root with no perfect square factors left in it. So we are going to remove all perfect square factors. So if our square root, if it's a perfect square, we'll simplify it, like the square root of 4 is 2, and be done with it. But if our square root is not a perfect square, we are going to look at it and try to write it in simplest radical form by removing all perfect square factors from it. The reason that we want to do this is because then we're still keeping our answer exact. We're keeping it exact. When you use a calculator and you put in a number that's not a perfect square and then you round it, that's an estimate. And sometimes estimating or rounding a square root is okay, sometimes it's not. So if it's not okay, if you need to have an exact answer, we are going to learn how we can write that answer sometimes in a simpler form. It's kind of like reducing a fraction. It's kind of like reducing a fraction to lowest terms. So there's a property that I'm going to write up here, the product of radicals. If we multiply together two square roots, so a square root of a times square root of b, that's the same as writing it as a single square root and multiplying together the a and b. So the square root of a times the square root of b is equal to the square root of a times b. So I'm going to use that idea in reverse here. And I'm going to take the square root of 32. Notice I've got a list of perfect squares written, the first 12 of them. What you need to figure out is the biggest perfect square factor of 32. So look for the biggest perfect square that divides evenly into 32. Okay, so I know that the number 32 falls here between 25 and 36. I cannot divide 32 evenly by 25. I can divide 32 evenly by 16. So 32 I can split into the square root of 16 times the square root of 2. 16 times 2 is 32, so I can write it as two separate square roots. Then the square root of 16 is 4, so I can replace the square root of 16 with 4. The square root of 2, though, is not a perfect square, so that is my answer in simplest radical form. The square root of 32 equals 4 times the square root of 2. Okay, my next example, square root of 75. 75 would fall over here between 64 and 81. If I check the smaller numbers, 75 does not divide evenly by 64 or 49 or 36. It does divide evenly by 25. 75 is 25 times 3. So I can split it into the square root of 25 times the square root of 3. The square root of 25 is 5. It's a perfect square. The square root of 3 is not a perfect square. So my final simplified answer is 5 times the square root of 3. next up, 200. 200 falls, way over here. After 144, my next perfect square is 169, then 196, and then 225. So 200 would be in between here. The first number though, so starting at the biggest, 196 is not dividing into 200 evenly. Not 169, not 144, 121, 100. 100 times 2 is the same as 200. The square root of 100 is 10, so simplest radical form, 10 times the square root of 2. We have 3 more examples, just like on the last screen, to get you some more practice. So 80, the biggest perfect square factor of 80, 80 falls here, cannot be divided by 64, 49, 36, or 25 evenly. It's divided evenly by 16. 16 times 5 is 80. The square root of 16 is 4, so 4 times the square root of 5. Next up, 54. 54 would be here. Does not divide evenly by 49 or 36, 25, or 16. It divides evenly by 9. 9 times 6 is 54. The square root of 9 is 3. So 3 times the square root of 6. My last one, 120. You may think, because 120 is a bigger number than the others, you may think that it divides evenly by one of these bigger numbers, but 120 actually only divides evenly by the 4. So 4 times 30. Square root of 4 is 2, so 2 times the square root of 30. The number 30, it's got a lot of factors. 30 has factors like 2 times 15, 3 times 10, 5 times 6, but none of those numbers are perfect squares. The only factors that help us simplify with simplest radical form are the perfect square factors. So 2 times the square root of 30 is done. Okay, now our next one has a 3 in front. A 3 in front of the square root of 12 already. So that means 3 times the square root of 12. So I am going to simplify the square root of 12 and break it down into square root of 4 times the square root of 3. Then, I know that the square root of 4 is 2, so I would get 2 times the square root of 3. The 3 that was out in front has to get multiplied by that new 2, so my final answer is 6 times the square root of 3. So this part, the square root of 12, simplified right here into 2 times the square root of 3. The 3 that was out in front here gets multiplied by the 2 from our simplified radical. So 3 times 2 is 6. So that coefficient number that's out in front of the square root is now 6. It started with a 3. Our new 2 got multiplied to give us 6. Okay. 72 splits. Now I could do 8 and 9, but that would not be the biggest perfect square factor. I need to use 36 here. 36 times 2. So the 2 that's out in front stays out in front. 36, the square root of 36 is 6. And these are all multiplied together. So 2 times 6 is 12. 12 times the square root of 2. It's our simplest radical form. You should be able to write a summary now, answering the essential question. Make sure that you use complete sentences.